Hi, let's get started with the robot design slides. So first we have a little bit about our team. So here's a little bit about our run strategy. The mat shown above is color-coded with the missions and runs. We divided the game into 4 runs shown in different colors in the slide, with different team members working on different missions. In the chart here, we're aiming for 540 points and we're hoping to get them. So we use a Spike Prime robot and the associated software to program and control the robot instead of EV3. The programming language we used was Python because all of us wanted to learn programming in this language. The robots and extensions have been built completely from scratch, and we made the robot more compact this year so it would be much easier to use and more stable.
The Spike Frame robot has two kinds of motors, medium motors and large motors. We used medium motors to control the extensions. One medium motor moves an extension up and down, while the other moves an extension left to right. The large motors are used to move and drive the robot in various directions. Also, something funny and coincidental. The back of the robot looks like a face if you look at it closer. Next slide. We use two sensors, gyro and color sensors. Gyro sensors were used to measure angles and turns. We used color sensors, which are evenly spaced apart on the bottom of the robot. They both do different jobs. One is used for the line follower, while the other is used for sensing different colors and stopping, turning, etc. when it senses black at different points throughout our code. These are the improvements we made from last year to this year. We sped up the removal of the extensions, improved the gyro and line follower codes, increased the compactness of the robot so that it can fit into tight spaces, and made our extensions stronger so that they can deal with tougher missions.
Innovative extensions. This is a multi-extension, and as stated by the name, it does almost every mission. It attaches the front top part of the robot and uses both of its motors. This attachment is an active attachment, which means it can be controlled by the motors and the robot and it's dynamic. In the first run, this is the only attachment we ever use. The spooner. The spooner is a cup that holds the innovation project, the helicopter cargo, and the normal cargo. It delivers them to the Cargo Connect logo and is a passive attachment, which means it's not controlled by the motors on the robot. The cargo carrier acts as a base to secure the green cargo. It makes it easier to put the cargo into the green circle, and it's a passive attachment, which gains us a bunch of points.
There were many examples of innovative programming in our runs. One example of this would be in our changes to the line and gyro follower. We added intervals, which allowed the line and other followers to go until they sense black for a total amount of times. We improved the code to make it more consistent and made the functions easier to use in general. Another important innovation would be in the programming tricks we use, like pushing the robot against the wall to align it and moving the robot until it sensed black. Finally, we made a user input for the sorting center. Because the sorting center changes every run, we made it so there are multiple codes, and depending on how much times a user presses a button, you can run a different thing in the same file. Here's the user input code that I was talking about. It used a combination of while loops and if conditions to work properly. Here are the line followers, and this line follower works much better than last year's, which makes the code much easier to work with. These are the two gyro pivots, which allow the robot to turn to a specific direction based on the gyro follower values. The gyro pivot regular is used for generally, but the gyro pivot to spec is meant for when the robot is turning around angles of 180 or negative 180. This is an example of an entire run for our code. This is run 2, and it gives us 130 points in just 20 seconds. You can see here. All the code is properly commented, so if any teammate needs to change it or cover for another teammate, they can review and make changes if needed.
We went through several iterations in our extensions. We removed one of the arms so the cargo blocks don't get stuck. And for the second extension, we made it much lighter and added another block which helps stabilizing the robot and gives us more points. And finally, for the third extension, we extended it a little bit so that we can complete certain missions.
Iterations in programming. Gyro Pivot 2. The robot was not able to turn past 180 or negative 180 degrees, and this is very annoying. So we altered the code so that we were able to make these turns without any errors. The line and gyro follower. We were having issues with exactly how far these followers are going. So we added intervals where we sense black to stop, and this helped the consistency of all of our programs. Finally, combining runs. This year, the sorting center run has 3 different modes, and it was hard to run the separate runs consistently. So he combined the 3 runs with the one and allowed for user input to pick which one you wanted and when.
Lastly, we have core values. We had a great time working on the robot mission. We solved problems, learned how to program in a new language, optimized our code and strategy, and did it all together as a team while having fun. Thank you for listening to our presentation.